The first question I missed had a diagram like this, and had point A here and point E here, and asked what the force was at point D. The issue that I made was that I thought that it was going directly to the middle, however, it said it was speeding up as well, which means that the arrow should have been something like this instead. The next question I missed asked about a circle, about the cart at the top of a circle like that. So for this equation, what you would do is you would do F centripetal equals mv squared over r equals mg, because the center is always positive, plus force normal. Then when you would subtract this, you should get mv squared over r minus mg equals force normal. What I did is I accidentally added that. I didn't consider mg as positive here, and I thought of it as negative. The next question I missed had a setup of u 0.05 kg and then 9.8 equals 0.05, 0.47, 0.1. And what I initially did is I didn't look at the units here, which I should have done. And that shows you that this is going to be u times mg equals mv squared. mv squared over r, because this is m. And then that helps you figure it out that it's a block set on a rotating surface, and that some friction is somehow involved. The next question I missed was asking about a satellite in an elliptical orbit around Earth, and asking what the torque would be. So like this. So what I did wrong here is that I said that it was non-zero when it was zero, because the torque, a torque would be applied on non to the center, and gravity is not a torque because it is applied directly to the center of an object, of center of mass of an object. So it would be non-zero, and that'd be because the lever arm of the speed gravitational force is always zero. Next question I missed asked if the magnitude of change in kinetic energy of the disk during the first 5 rotations, how does it compare to the magnitude of the change during the last 5 rotations? And for this problem, what I did wrong is I didn't think about it in terms of t, or in terms of t times theta equals work, yeah, because it says that there's a constant torque. So if the torque is constant and these are both 5, then they should be equal to each other. If theta 1, so if t theta 1 equals t theta 2, then these are just completely equal equations, because theta 1 and theta 2 are equal because they're both 5. So it is the same during the first 5 and last 5. And then the last question I missed was about angular momentum. And angular momentum is equal to mvr, like that. So if you substitute omega, which is what it's asking for you to solve for, you get r squared, like that. And then finally, what you would do is that you can plug in, because it says the radius would be 1/2 and the mass stays the same. So if you put it in r 1/2 here, you would get 1/4 mr equals m final. So for this to be equal to each other, m final would have to, or omega final would have to be 4 times omega initial, which is how you would get the answer to 4. And what I initially did wrong is that I got the opposite relationship, where I thought omega r would, or vr is equal to omega, which is the wrong equation. And yeah, that's my test corrections.